Can you see the screen? Hello?
Yes, sir.
Yeah, we are discussing now design and mounting of the punches. So how to design and how to mount the punch. So this is a simple drawing, that is how to mount the plain punches. Just have a look. So if it is plain punches, you can just mount it by threading. Like you have a plain hole here, and then you are in the plain hole, you are putting a threaded bolt, and to this threaded bolt, you will mount a punch here. So in the punch, there will be a tapping, and in that tapped hole, this bolt will go, so that this bolt will hold the punch firmly. The problem in this case will be, since there will be a play, see threaded joints, there will be always a play in the male and female piece. So you will not get a good accuracy of mounting the punches. That is, the punch will not be concentric to this center line, because there is always some amount of clearance in threaded joints. If it is a flange type punch, just now I'll give some time for reading and understanding this drawing. If it is flange type punch, so this is a punch here. I'll zoom it. This is a punch. This is your stock or strip. So 3D view of this punch is also shown here. You can also check from the top view how the punch is mounted. So the punch is of rectangular shape. This is of rectangular shape, and it is held with the help of these four bolts. These are the four bolts. Now, can anybody tell me what are these two holes? ये जो दो होल है वो काय के लिए है? Anyone?
सर लोकेट करने के लिए.
Yes, and these are the holes for the dowels. These are called as the dowel holes. So with the help of these dowel holes, your punch will get located precisely. So these holes are actually rimmed holes. These are the rimmed holes, and this is the punch. Okay, so now this is not a round shape. It's a rectangular shape, isn't it? That means the orientation of this is very important. Okay, it should come perfectly parallel or perpendicular to the edge. So it should not be fitted. This punch should not fit cross. So for that, these dowel holes are provided. So dowel holes are rimmed hole in which you are fitting up the dowel pins. Dowel pins are available 6 mm, 7 mm, 8 mm, and these are ground. These are all ground holes. Ground holes. So depending upon the size of the punch, you can decide upon whether to go for the 4 bolts or whether to go for the 2 bolts. Even the 2 bolts and 2 dowel pins are sufficient. These are called as the perforator type of punches. Perforator type of punches are used for punching the small holes. Channeling, जो sieve रहते हैं, इसमें there are number of holes. So if you want to punch those number of holes, then the punches used for such a kind of holes are called as the perforator type. Just have a look on how these punches are mounted. A, B, and C. These are 3 different designs for mounting the punches. So this is called the punch plate, and this is your back plate, and this is punch holder. Back plate is a hardened plate because the punches are always hardened. So in order to prevent the damage to the punch holder plate, we are fitting a backup plate. Backup plate is usually thin and punch holder plates are thick. So in order to prevent this damage, we are inserting a backup plate. Now this punch goes into this hole, tight fit, and in order to prevent falling down, we are fitting a set screw, or also called as the grub screw, from the side. So this is called as the side locking. Remember, wherever this screw is clamped from sides, you have to grind a flat on the punch. Otherwise, this screw will not rest on the punch properly. So आपको हल्का सा वहाँ पे फ्लैट ग्राइंड करना है पंच के ऊपर, so that the screw can rest on that flat properly. This is another design. अभी इसमें कैसा है? It is plain. Now in this punch, you have a counter bore here. You have a counter, so there is a head. Okay, so this is also called the headed type of punch. So यहाँ पे you have a counter bore, and this is tight fit. Whereas here there is a clearance. यहाँ पे आपका clearance रहता है. Now here that clearance is not shown, but whenever you are drawing, you have to show this clearance, because you cannot have tight fit here and tight fit here. There is no clearance here or here. It means it is tight fit. So here you have to draw one more line like this and one more line like this. Okay. Otherwise that becomes redundant. Then you have third type of design, and here A is equal to 2B. So if this clearance is 3, then this should be at least 6. Now here the mounting is shown for the two punches which are close by. One is large punch and another is very small punch. So the large punch is mounted with the help of the bolt, a threaded bolt, and this bolt has been fitted. It is clamped from the bottom. This clamp is clamped from the bottom. Okay. Then you have another small punch which is fitted like this, having a head, and either it can be directly fitted inside this punch, or you can use a bush to fit this punch. Preferably, if there is a place, then you can use bush. If there is no place, then you have to go for the bush. Sorry, if there is no place, then you avoid bush, and if there is a place, then you go for the bush. So it depends upon the size of the punch. Any design is okay. This bush is also not required. It is not necessary, because it's not working. This punch is not working. Working means what? This punch is not moving inside the bush, like our drill, which passes through the drill bush or jig bush. So we say that that's a working area. So that's why we have to make drill bush or jig bush harder. These are some different designs for mounting the punches. Now this design is more common. This, remember, this design is more common. So you can, for your crystal design, you can go for B, this design. Alright, so this is what is your spring loaded. Then you have a threaded designs. So this is a slender punch. Slender punch matlab it's very slim. So for this slender or slim punch, we are using one bush, okay, which is fitted inside this plate. This is again a slender punch. Now the purpose of this bush is, this bush you can extend still down till here. See, let us assume that say this is your working area of the punch. That is only this much portion is going to cut. Okay, so you can extend this bush so that the support is good. Hmm? So that the punch will not buckle or punch will not bend. So bush type of design is preferred for slender punches. These are some few more designs. This we have seen already. You can also see now this is shown properly. There is a clearance here. So this is not a redundant. Okay, there is no clearance. So it is tight fit here, and the head there is a clearance between the counter bore and this head. You can go for countersunk also. Again, you can have clearance here and go for countersunk also. Or you can go for threaded type. This is the first slide which I showed. That is, you have threading or tapping inside the punch, and then you can bolt it. Only the issue with this is that additionally you have to do tapping inside this punch, plus you need to do drilling and counter hole in this punch holder plate. Whereas here this operation is not required, that is drilling and counter boring. This is not required in this. As well as this drilling and tapping inside the punch, that is also not required. So that's why this is more preferred. So what is required is just a counter bore here. That's all. See, there are few more designs for supporting the slender punches. Like this now here, you have a quill. Through which this punch is passing. So now this quill or this bush is extended. Hmm? And you need to extend as far as possible. Of course, you have to see or you have to take care that this bush doesn't hit the strip. Here you have one more design, that is one more plate is provided for supporting the slender punches. So now the punch, the slender punch is being guided through one more plate. So it acts like a beam having supports at both the ends, at two ends. Here it will act like a beam which is supported throughout, only the end portion is not supported. Other design is, like say now this is the punching diameter, let's say 3 mm. Okay, 3 mm is the punching diameter. So you need not make this punch 3 mm in dia throughout. The working area will be only the strip thickness. and maximum strip thickness what you can do on press is 5 or 6 mm. So why to unnecessarily make this punch slender throughout? So you can have only 10 mm portion which is of diameter 3 or diameter 2. See, if the strip thickness is 2 mm, you can have this length as 3 mm. But why we are keeping 10 mm? Because after certain stampings or pressings, the punch becomes blunt. So you need to regrind it from the bottom in order to use it, in order to increase the life of the punch. So that's why we are keeping 10 mm. Okay. So after 1 lakh pieces, you can grind it. That doesn't mean that you have to keep it of diameter 2 mm throughout. Only 10 mm is enough because the grinding is hardly 0.1 mm. So even if you are keeping 5 mm extra, so 5 divided by 0.1, 5 divided by 0.1, so that is 50. So 50 times you can grind it, and in between two regrinds you can do 1 lakh pieces easily. That means if you are grinding it 50 times, you can do 50 lakh pieces. You can have 50 lakh strokes. So what I am trying to tell that you don't have to make this punch slender throughout. So you can increase the diameter of the punch at the top. Okay, you can make this taper, right, sir? So you can have say 10, if this diameter is 2 mm, you can make this 10, then you can make this 5. Okay, then 5 se leke gradually you can have a taper, and then gradually you can make this 2 mm. So now this punch is well rigid. This is another arrangement, that is you are fitting a punch, a slender punch inside another punch which is more in diameter. मतलब punch के अंदर punch. Or you can have number of punches in a big punch like this. So one, two, three. Three small punches are being fitted in big punch. Then the bottom, see in the press, the top portion is called the punch and the bottom portion is called the die. So just have a look on how to secure the die blocks. I'll just join you in a minute. Yes, so the top portion is called as the punch and bottom portion is called as the die. So usually the entire die is not made up of steel, you know, like the type of steels what we use. Now I have been telling you MS, but the portion that is punch portion which is going to cut inside the die, uh, those are made up of steels like OHNS, that is oil hardened non-shrinking steel, or WPS, that is high carbon high chromium, that is D2, D3, D4. So these steels are expensive. So you cannot make entire die block from high carbon high chromium or from OHNS, that is O1, O2, because it becomes very expensive. So only where the cutting is desired, so उतना portion जो है that only is made out of high carbon high chromium, और जो बाकी का जो रहता है that is MS. So in this MS we are now fitting this die. Okay, so this is totally MS, that is one part number one, that is for the die holder. Then second is die block. So now this is the block in which the cutting is happening, or this is a block in which there is a cavity. All right. So one purpose, one advantage of this is your cost becomes less, your cost reduces. And second advantage is many times what happens after 2 lakhs or after 10 lakhs, that is after 1 million pieces, this die get damaged. Okay, the shape, the area, the shape which is cut in the die, hmm, the profile which is cut in the die, that gets damaged. So there are only two ways: either you can repair that or you have to scrap it. So if assume that if the profile is cut in this die holder, that is pura jo solid block, then you have to scrap this entire die holder, which is a big block and which is very expensive. So instead of that, if we have this replaceable type of die block, this is for the replaceable type of die block, then you can only change this. Okay, and the third advantage is that you can have a spare die block. You can have this spare die block. So moment this is damaged, जो spare die block है उसको लेके you can just fit it. Okay, so that will take only 5 minutes. तो आपका जो डाउन टाइम है that is not there. अगर ये पूरा had it been from the solid, that is पूरा MS block में से had it been from the solid, then you need to, if you want to repair it, then you have to send it for welding department, brazing department, then again grinding, again cut, wire cut, etc. So that will take time. Okay, so if it is replaceable type, then you can keep this die block as a spare, and then your downtime is reduced like anything. Now how to put this die block, how to put this die block? So there are various ways. See, this is your die block. So you can fit it with the help of the Allen cap screw. Allen bolt is also called as the Allen cap screw because this looks like a cap. And this is a dowel. This is a rimmed hole. This is a rimmed hole. This is just for alignment, for aligning the die block. Okay. Now this threading, this is not a good design because here the tapping which is done in the die holder is blind, is halfway. So in order to reduce the machining cost, what you can do, you can drill this hole through as well as you can tap this also throughout. You can tap this throughout. So if it is a through hole, then drilling is also easy and tapping is also easy because the chips while doing tapping can fall down easily. Whereas if it is a blind hole, then we give you tapping difficulties because every now you will have to, while you are doing the tapping inside, every 5 mm you go down, you have to remove the tap, clean the chips, again start the tapping. Like that you will have to do. So it is always preferred, if possible, then go for through and through drilling and tapping, if possible. Huh? If possible. I have used the word if possible. Then Dowel hold is a rim roll. Now again another mistake what the student do, that they show the threading in this as well as in this. That is, they show the threading in die holder as well as in die block. So remember, the threading will be only in the die holder and there will not be any threading in the die block. So here this is again a mistake. Here it will be only a clear hole, clearance hole. Okay. So these two lines are for the threading and there will be one more line showing the clearance. For example, suppose if this is M8 ka hole, if this is M8 hole, okay, then this you can have 9 mm ka hole, drill hole, hmm, so that your bolt will pass easily, and will hold it. Similarly, this also is a clearance hole. Suppose if the diameter of the head, suppose this is M8, and if the diameter of the head is 16 mm, then you can make this 17 mm. Okay. Similarly, you can bolt it from the down also. So you have to check the possibility whether if there is a sufficient space in the die block, then you can do it from the top. Sufficient place means for the counter bore. Like suppose if M8, generally the head is twice. So if it is M8, this will become 16. So if there is a space in the die block, then you can do it from top. If there is no space, then you can do it from the bottom. Okay. You can also, you know, have taper wedge. So if you are doing with the help of a taper wedge, then dowel is not required. There is no need of dowel. Dowel hole is not required. Hmm. This taper will locate your die block properly. So this was how to mount the punches. Now let us study knockout. Huh? Knockout is nothing but ejector pins. Knockout is nothing but the ejector piece. So it is required to remove the punched piece properly. I'll zoom it. So knockout is nothing but ejector pins. Just have a look on this drawing, try to understand this. Hope you are able to understand this. So this is a blanking die inverted. Why it is called the inverted blanking die? Because the punch is operating from the bottom. So this is the punch here. Remember, this is the punch. These are the springs. You must understand now the various conventions. This is the spring, this is the spring, and this is the punch. This is the stock or this is the strip. ये आपका डाई है. Okay, so the punch operates from here, and this is your blank which is cut. Okay, now ये जो blank है, this blank is this elliptical in shape. And in this blank there is a hole to be punched. So how does this operation takes place? Can anybody tell me how this blank is removed from this diagram? Are you able to understand? Hello? Hello, Hasnain, can you tell me? Hello?
Yes, sir.
Are you there, Hasnain? Yeah, can you tell me how this is removed? How this is removed? How this blank is removed? Can you tell me? Ashish,
Yes, sir.
can you tell me how the blank is removed? This
सर स्प्रिंग लोडेड है ना बाजू में, तो लाइक वो
ये
जो
जो
पंच के साइड का जो एरिया है,
ये स्प्रिंग्स है. हाँ. हाँ.
स्प्रिंग्स के ऊपर का जो भी पार्ट है वो, आई डोंट नो द नेम.
हाँ.
So like while punching, that thing goes down, and when the punch is completed, that thing goes up, and the blank is.
हाँ. ये ब्लैंक नीचे गिरेगा कैसा? दैट इज व्हाट इज कॉल्ड द नॉकिंग आउट. इट इज वेरी सिंपल. ये जो होल है ना, कैन यू सी दिस होल हियर? यहाँ पे जो होल है ना, वो होल में से भी पास द एयर and there is a hole which is drilled. A small hole is drilled. Okay, and moment it comes up, the air is forced inside this, and under the air pressure, this blank it falls down. Okay,
Yes,
understood?
sir.
Slender piercing punch. Like now, these are the slender piercing punch. They are guided by the hardened bushings. Okay, so now this is a knockout plate. ये जो है, ये छोटा दिख रहा है वो knockout plate है. And these are the punch. Now these punches are guided in this bush. Alright, so when it comes up, ये जो plate है, हाँ, again there is a hole here. Okay, जिसमें से हम लोग हवा छोड़ेंगे, and this air will eject out this blank. Now these punches are very slender. Okay, so that's why they are guided within this bush, and these bushes are kept or fitted inside the knockout plate. So this is what is called as the knockout plate. This is the bush, and these are the slender punches. This is a blank which is being cut out of the strip. Now suppose if you want to eject or knock out the shells or small cups. So positive knockouts means you are using some external device or a punch to knock it out. Now this B is nothing but drawing punch. Okay, this C is a support pad. ये जो C है, that is a support pad which is supporting this, so that you get a base perfectly straight and flat. Okay. So now when it goes up, okay, so this plate, you know, which is under the spring, will press this down. Okay, this is going to remain here only. When it goes up, this spring which is compressed, ये जो spring जो दब गया है वो खुल जाएगा, वो ये प्लेट को दबाएगा. ओके, ये पूरा प्लेट है, ये ऐसा हैचिंग दिखा है, डबल हैचिंग. सो ये प्लेट को ये स्प्रिंग दबाएगा, सो दैट दिस प्लेट विल नाउ प्रेस दिस कप डाउन. बराबर है. अगेन आई विल टेल यू, ये जब भी खुलेगा तभी यहाँ से ओपन होएगा, डाई विल ओपन फ्रॉम दिस. यहाँ से आपका डाई ओपन हो जाएगा, खुल जाएगा. ठीक है. एंड मोमेंट दिस गोज अप, ओके, सो नाउ द स्प्रिंग इज कॉम्प्रेस. मोमेंट दिस गोज अप, द स्प्रिंग विल, जो कॉम्प्रेस है वो खुल जाएगा. हाँ, वो टेंशन में आ जाएगा. बराबर है. तो टेंशन में आ जाएगा तो ये प्लेट को दबाएगा, प्लेट सी, और ये प्लेट इसको दबाएगा, आपका कंपोनेंट को. ठीक है. ओनली यू हैव टू सी दैट ये जो ओपनिंग है बिटवीन द डाई, बिटवीन द टॉप एंड बॉटम, दैट शुड बी मोर देन कप का हाइट. देन ओनली इट कैन बी इजेक्टेड आउट. नहीं तो उसके पहले करेंगे तो जो है वो फंसेगा, जो कप है वो फंस जाएगा. इफ द डाइज आर large, okay, like this is very large, say 100 mm or 200 mm, then you can have spring loaded knockout. This is a knockout here, okay, and this is spring loaded. ये आपका spring है. This is a convention to show the spring. This is what is your spring is. So when it goes up, ये spring है वो खुल जाएगा, and स्प्रिंग है वो इसको पुश करेगा, ये ब्लैंक को. व्हेन दिस गोज अप, जब ये ऊपर जाएगा. बराबर है. अभी कैसा है, स्प्रिंग दबा हुआ है, स्प्रिंग इज कॉम्प्रेस्ड नाउ. जैसा ही ये खुल जाता है, ये जैसा ही ऊपर जाता है, तभी क्या करता है, ये स्प्रिंग है वो इसको दबाता है, ये प्लेट को. ओके, विच विल पुश दिस ब्लैंक डाउन. ओके, so this is for the larger dice. Then you can use your pressure pins and stop collars. Use your pressure pins and stop collars. This is not much common. This is not much common. Even indirect knockout is also not much common. Okay, so you need not worry much about this. You can have different shapes of the spider knockout plate. Nobody does like this spider वगैरह. Everybody goes for a rectangular knockout plate. Okay. So the knockout plates can be spring loaded, or if in addition to this spring loaded knockout plates, you can have air force. Okay, you can have air force. Whenever the spring loaded arrangement is not there for the knockout plate, So that time you have to eject out with the help of the air pressure. So these are the holes for passing the air. This is a spring loaded nozzle, or it is also called as the pressure pad. Now ये जो है वो पंच है आपका. Okay, so when it goes up, अभी क्या है, ये दबा हुआ है, ये जो है ना, this pressure pad, दब गया because of that ये जो spring है वो भी दबा हुआ है. Okay, now moment it goes up, इसका प्रेशर इसके ऊपर से निकल जाता है. नाउ दिस स्प्रिंग विल पुश दिस प्रेशर पैड अप. ये देखो, ये इतना खुला जगह है, इतना इतना खुला जगह है. ओके, यू कैन सी दिस हॉलो, बराबर ना. सो ये जो हॉलो है उसमें आपका ये जो प्रेशर पैड है वो मूव होएगा एंड इट विल पुश दिस ब्लैंक अप. ओके, नाउ इन दिस केस द नॉकिंग आउट और द इजेक्शन इज फ्रॉम बॉटम. Same here also. You have spring loaded pressure pins. So जैसा ही it goes up, जैसा ये ऊपर जाता है, दिस प्रेशर पिन है वो, ये जो प्रेशर पैड है, ये दिस प्रेशर पैड उसको पुश करता है. एंड दिस प्रेशर पैड कैन मूव अप because see there is a clearance here, and this clearance depends upon how much movement you want. Okay, अगर आपको 10 mm movement चाहिए, okay, so this will be more than 10, maybe 12 or 30. This is a typical pressure pad design. ये ऐसा pressure pad रहता है. Okay, this is the size and this is the thickness of the collar. Plus ये यहाँ से लेके यहाँ तक ये जो height है, this depth will depend upon how much you want to eject out. अगर 10 mm आपको eject out करना है, so it is good practice to keep it 12 mm. Okay. You can now whenever you are doing bending, so in order to get a flat surface, you have to use the pressure pad. So these pressure pads applies the pressure and keeps this portion flat. Okay. So this is your L type of bending. This is your L bending. Now here the pressure pad is provided from the bottom. The जो dark portion है, that is nothing but your strip or the product. Now this pressure pad from the bottom will make this surface flat. And this is the punch. This is what is your die block is. And this is your pressure pad and this is a punch. We'll push it down. Now look at the clearance between this die and the punch. This clearance should be such that your strip should go inside. आपका जो strip है should go inside. When you are doing operation like drawing, बराबर है, when you are doing operation like drawing. You can also have spring loaded pressure pad like this, which helps in pressing the component. Now this is what is your air holes is. Air holes. So these air holes are enough to eject the component. Similarly, here the air also can be passed from this side, which will be helpful to ejecting out the component. So that was about your locating the punches and locating the pressure pads and how to eject the component. So we will stop here. If you have any doubt, you please ask.